Oh, I saw a baby bison. My mom.
All right. Just want to make sure that we understand the bell schedule for this week. We're going to be following advanced bell schedule this entire week. So all the times are going to be a little bit off. We want to take a picture of that. That will be our bell schedule. And reason why we have that advisement every day is because they want to get all the drills in this week. So I think we're doing some drills on fire drills and yeah, and other I think all the things that we have to do starting on Wednesday. So either they're going to split it all between different days, or they're going to run them one after the other. Okay, so let me. Okay. Also, the handouts that you guys picked up. If you have printed out Matrices packet, then hopefully you're not picking one up. But if you did, just let me know, just so that I can make sure that selling period gets the number of packets that they're going to pick up. But hopefully, those of you who already have a packet, you can just use that one. It's the same one as the one over here that I have in front of the class. A calendar you can also pick up, and then also quiz review. So okay. Your quiz is going to cover from 5.01 to 5.03. I know the packet says 5.04. That's just splitting up the inverse notes into 2 sections. So we're almost done with the notes. Just 2 problems that I want to kind of go over with you in person. And then we'll go over the review sheet. I'll have another review for you tomorrow. Also, at the end of class tomorrow, I'm going to be walking around and checking your packet. So I'm going to be checking that you're doing all the problems that we've done over the course of the past last week and this week. So, okay, and the quiz will be on Wednesday. Okay, any questions? Okay. If you guys can turn to page 11, I want to review finding inverses, and then I want us to do 2 problems, bottom of page 11 and bottom of page 12. Okay, so page 11. So we talked about how if you want to find an inverse of a matrix, there's a couple of procedures that has to happen, right? So the first thing is we have to make sure that we know how to find the determinant. So determinant is a portion of the inverse procedure, right? So determinant is AD minus BC. We basically kind of go through this cross multiplying procedure. We start at the upper left corner, A times D minus B times C. That's going to get you a number, and that number is going to go in the denominator of the coefficient of your matrix. Okay? And then the next part to create the inverse of your given matrix is you have to do some arranging and changing of your 2x2 matrix. First thing you do is you take your first diagonal and you make the 2 values swap places. Okay? Don't change the signs, just make them swap places. Okay? And then going to the other diagonal, you're just going to make them change signs. Okay, don't make them change places, just make them change signs. So we did example 1. Let me just go through that real quick here. So example 1, first thing is to find the determinant. So we always start at the upper left corner. 2 times 4 minus a negative 12. So we have to make sure with determinant that you're keeping track of your negatives, and that if you see 2 negatives, that you're going to make it positive. So 2 times 4 minus 4 times negative 3, which is 8 plus 12, which is 20. So once you have that 20, then that goes in this determinant slot of your matrix, which will be for your inverse. So you'll do 1 over 20. Okay, and then you have to do some adjustments with your matrix. You look at your original matrix, take that A times D, and you're going to make them swap places. So the 2 will become a 4, and the 4 becomes a 2, right? Make them swap places. Now going to the other diagonal, you're going to make them change signs. So this 4 will become negative 4, and this negative 3 will become positive 3. Once you have that, then you basically have your inverse. You're just going to be cleaning up a little bit more. So multiply every element by that fractional coefficient. So 4 over 20, 3 over 20, negative 4 over 20, and 2 over 20. Reduce all those fractions, we get 1/5, 3/20, negative 1/5, and 1/10. Okay. Are we good with the inverse procedure? Okay. Now, the problem at the bottom of the page is a little bit more involved, but we'll go through it slowly, okay, just so that you can get comfortable with the process that we're about to do here. So it says, given matrix A is this 2 by 2 matrix, and that A times B is this matrix. It says to find matrix B. So this is a little bit different here because we have A, we know that A times B equals AB, but it's not a straightforward problem where you're given matrix A, matrix B, and you're multiplying. It's almost like we have to kind of find matrix B that causes the product to give us this result. Okay, so it's a little bit different here because it's not straightforward, but let's just set up what we know to be true. We know that matrix A times matrix B is equal to matrix AB. Okay, that part we know. We have matrix A, we have matrix AB, we just don't know what matrix B is. What we're going to do is we're going to rearrange this so that we can solve for matrix B. Okay. So from a multiplication standpoint, if I had 2 terms multiplied together, I would divide if I want to isolate one variable. But with matrices, it's a little bit different. We're not going to divide, we're going to do the inverse. So what we're going to do is we're going to find a way to get this A over to this other side because we want to solve for B. But the way to get that A to the other side, we're going to basically make it the inverse. Okay. If we take the inverse of both sides of the equation, we get the left side to go away, and it appears on the right side. So this is what it looks like. We have, if I want to find matrix B, I'm going to have to shift that matrix A to the other side. It becomes the inverse. Now, when it becomes the inverse, it's important that you put it first. Okay, it needs to come first. If it comes second, it's going to mess things up. So it's going to become matrix A, inverse of matrix A times matrix AB. Okay, does that make sense? Okay. I know that we're used to maybe thinking in terms of dividing something over to the other side to solve for B, but with matrices, the way you move matrix from one side to the other is you take the inverse. Okay. So here's what we're going to do. We're going to, yes, question?
Why would it be month instead of this?
Oh, you mean this?
Yeah.
This is a multiplication.
Oh, okay. Sorry.
Yeah. So when we make that matrix A go over to the right side, becomes inverse of A, but then it becomes a multiplication of these two. So when we rearrange it, we basically have it where, okay, if I multiply the inverse of matrix A with matrix AB, I can work this out and get to matrix B. Okay, so we're going to have to spend the time to figure out the inverse of matrix A. Okay. After that, then we'll multiply this with AB, and we go through that process, and we can go work. Basically, we're working backwards to figure out what matrix B is. Okay, so then we're going to turn our attention to figuring out matrix inverse of matrix A. Okay, so let's find the determinant, AD minus BC, right? All of our attention now is to figuring out what the inverse of matrix A is. So AD minus BC. Eight minus 6 is 2. So let's build that inverse matrix A. We know our formula is 1 over determinant, and then we're going to rearrange the 2 by 2 matrix in the form that is matching with our formula, right? Swap the A and D, but then just change the sign of the other matrix. Okay, so we're going to swap the 2 and 4 and change the sign of the 1 and 6. Multiply that 1/2 through, and we should be sitting at an inverse matrix we can then use. 4 times 1/2, 4 divided by 2 is 2. Negative 1/2. Negative 6/2, which is negative 3. And then 2 times 1/2 is 1. Okay, are we good so far? So now we're almost there. We just have to figure out how to solve for matrix B. Matrix B is the inverse of matrix A, which we have here, times the matrix AB, which is given here. So I'm just lining up everything that I've determined from the very beginning, right? We spend most of our time figuring out inverse of matrix A. And now that we have a matrix for that slot, we can put that in. And then AB is already given to us. So now we just have to multiply these two matrices together. I like to put them kind of diagonal from each other so we can kind of see exactly how the rows and columns are going to be paired up. If I multiply a 2 by 2 with a 2 by 2, I know that I'm going to end up with a 2 by 2, right? The middle numbers matches up, and then the outsides is the result of multiplying two matrices together. Yes, question? Yes, sorry, 1/2 is negative. I did not carry that over. Okay, so negative 1/2. Okay, thanks. 2 by 2 matrix. All right, let's practice our multiplication steps. You're going to match row with column, right? You're always going to start with the left side, and you're always going to start at the top of the second matrix, right? So pair up, multiply, and add. So 2 times 30. And then 21 times negative 3. Okay. Second row, first column, 30 times negative 1/2. Then next up, 1 times 21. 2 times negative 20. 3 times 14. Negative 1/2 times negative 20. 1 times negative 14. Okay. Clean up. We have 60 minus 63, which is negative 3. Negative 15 plus 21 is going to be 6. Negative 40 plus 42, which is 2. And then we have 10 minus 14, which is negative 4. So this confirms that matrix B that we're looking for is negative 3, 2, 6, negative 4. If we were to go back and double check, if I were to multiply matrix A times matrix B, I will end up with matrix AB. It just feels more involved because it's not as straightforward as just multiplying two matrices together. We have to kind of rearrange because we're given matrix A and matrix AB, and we're having to kind of go backwards to figure out matrix B. Any questions about that process? Okay, there's also the other problem, number 5 on the bottom of page 12, but we'll save that for tomorrow for practice. Let's go to worksheet, the quiz review that you guys just picked up. I'm going to walk us through most of these problems, and hopefully by tomorrow you'll feel like you'll be able to kind of move through the problems on your own and then be ready for Wednesday's quiz. All right, number 1 it says perform the given operations. If it's not possible, write undefined and explain why. So number 1, are we able to add or subtract these two matrices together? No. Okay. So if we're dealing with addition and subtraction, they have to be a perfect match, right? Multiplication, they don't have to be, but we have a different method of determining whether multiplication can happen. But addition and subtraction is just very straightforward. If the dimensions are not exactly the same, we're not going to be able to multiply them. Okay. Okay. Number 2, is number 2 possible?
Yes.
Yes. Okay. So I would think of this as a 2-step process. I would take care of the first scalar multiplication. So we can distribute that 3 through. Once you distribute that 3 through, you're still going to be left with a 2 by 3 matrix. And then you can worry about subtracting the elements with the second matrix. Careful though, we're subtracting. So you have to make sure that you keep track of your negatives, right? If you see 2 negatives, you got to make it a positive, especially, right? If there's a negative that's coming from the second matrix, you got to keep track of the fact that, oh, there's 2 negatives there. I got to make some adjustments. Okay, so try that. right, check our answer for number 2. First things first, multiply 3 through the first matrix. Now you're just going to subtract each element. -9 minus 4 is -13, right? -6 minus a -1 is -6 plus 1, which is -5. And then we just go down the line and subtract each element, each of the corresponding elements, and we should still end up with a 2 by 3 matrix at the end. Okay. Any questions here?
Check that, and then I just came back.
Okay, sure. Okay, any questions with 2? All right, look at number 3. Number 3, this is a 2-step process here. We're just going to worry about multiplying the first 2 matrices together. And we're hoping that if this is going to work, that the resulting matrix will match the second one, so that, the third one, so we can subtract them. But first things first, we're going to have to decide whether these 2 matrices are even possible to be multiplied. Okay, so we have those conditions to go through, right? Identify the dimensions of each matrix. See if the inner dimensions are the same. If they are the same, then you know that your end result is going to be the outside dimensions. Okay. Any questions with 2? Are you guys okay with 2? Okay, let's look at number 3. Okay. First matrix is a what dimension here? 2 Second matrix is a 3 by 2. Are these compatible? Yes. Middle inside numbers matches. That's the condition. But you know that your matrix that's going to come out of the multiplication is going to be a 2 by 2. Okay, so let's spend the time to set things up so that we can get them lined up in a way where it's easy to know how the numbers will be paired up. Give myself more room here. Okay. For the rows, go from left to right. For the columns, go from the top to bottom. Okay, any questions about how those numbers are paired? And yes, question? Which one?
8.
8. Yeah, the vertical bar needs to be fine.
Oh.
Two rotations. Yeah, fine. She'll show the local multiplication, but then just indicate that, okay, this is what I have. But on the quiz, I'll make it.
Okay, thank you.
That's good. Okay, so after we get the results of the product, we still have to worry about the second part of the problem, right? We still have to subtract that 2 by 2 matrix. So the resulting matrix should look like this: 44, 73, 12, and negative 33. So there's my resulting matrix. I'll have to subtract my third matrix here. Check your answer with number 3. Any questions?
Is that 36 or 30?
Oh, 30.
Oh,
30.
okay, yeah.
So I'll clear that up. Okay, try number 4 on your own. Number 4 is another multiplication problem. Go through your process, make sure that they're compatible. Find the dimension of the first, find the dimension of the second, see if they're compatible, and then see if you can decide what the resulting matrix will be. Yeah. Oh, yeah. I think you're doing too much. This is just fine to start up. You're just going to stop at DET and F. That just means fine. That's right. Okay, number 4. You do need to multiply this 2 through that second set of matrix, but ultimately the dimensions is already set. What's the dimension of the first matrix? Second matrix is a what? 6 by 1. Are these compatible? Yes. The inside numbers have to match. Once you get that confirmed, then your matrix is just going to be the outside numbers. It'll be a 1 by 1 matrix, 1 row and 1 column. Okay. You just basically have to add and multiply all the numbers along that column. So it's only a 1 by 1 matrix, but there's a lot of numbers that's going to go in that element. So the first matrix, you're just going to read from left to right. The second matrix, you're going to go from top to bottom. But make sure you make the adjustment with the second matrix, right? You got to multiply all these elements by 2. And then just start pairing each of the terms up. 2 goes with 8. 3 goes with -4. -1 goes with 2. And they're all going to go in that 1 by 1 matrix. Yes. Okay, what about number 5? Can we multiply those together? Okay. Are they compatible? No. Okay. 2 by 4 does not go with the 2 by 4, even though the dimensions are the same. Our condition required for multiplication is that the inside dimensions have to be the same. The 4 and the 2 are not the same, so we can't. Now, if we were trying to add these together or subtract them, they will be fine, but multiplication requires a different set of conditions. Okay, let's go to the back page, focusing on inverses and determinants. Are we okay with the first page? Okay, second page. determine if matrix A and B are inverses of each other. So by using matrix multiplication, if matrix A and B are truly inverses, then this should happen. I should be able to get matrix A and matrix B to cancel out with each other, leaving me with 1, 0, 0, 1. That's the inverse. That will show that matrices A and B are truly inverses because it's like multiplying 3 times 1/3. They're going to cancel each other out, leaving me with just 1. A 1, 0, 0, 1 is basically the matrix version of quote unquote 1. So the way that we're going to test this out is we're just going to multiply matrix A and B. If it looks like this, then we know that we can conclude that the two matrices are inverses. But if it doesn't look like this, that means they're not inverses. So that's the only decision we have to make. Just multiply it out and see if you get this, then you can conclude that they're inverses. If it doesn't, then it's not inverses. So line them up. You know that you're ending up with a 2x2 matrix because your dimensions, inside dimensions matches. And if you're working ahead, I just want to talk about 7 and 8. 7 and 8 just means find the determinant. So if you see DET or the vertical bars, that just means find the determinant. And that's easy, right? That's just AD minus BC. And then number 9 through 11, you're just going through that process that we did, right? 1 over the determinant, and then you have to make those adjustments inside your 2x2 matrix. Okay, so here's number 6. When I multiplied A and B out, I did not get 1, 0, 0, 1. So I know that matrix A and B are not inverses because if they were, then they should be giving me a 1, 0, 0, 1. Just means that your determinant is 0. Once you set it up, you can solve it out. Okay. Number 7 and 8, you're just finding determinants, so just AD minus BC. And then 9 through 11, you're doing the full process. You're involving the determinant to create the inverse. Any questions with 7 or 8? Okay, try number 9. So number 9 through 11, you're just going through this process, right? Getting to that determinant, putting it as a fractional value in front of your inverse matrix, and then looking at your original matrix and making your adjustment with your 2 by 2 matrix, right? So flip or swap places for your first diagonal, and then change the signs of your second diagonal. Okay, so again, AD minus BC is your determinant. -2 times 1 minus 0 times -5. So that gives me -2 minus 0, which is -2. That -2 is going to go in the denominator of your fraction outside the matrix. -1/2 comes first. Then you have to make some adjustments with R. So make the -2 and 1 swap places. 1 goes up here, -2 goes down here. And then change the sign of your other diagonal. -5 goes to 5. 0, we can't change the sign of 0, so 0 will stay as 0. Now let's just multiply a -1/2 for all the elements. So here's our resulting 2 by 2 matrix. All right, number 10, try number 10. Mm-hmm. Okay. Any questions with 10? Okay, number 11. Yes.
So wait, how did you get 1/2 instead of -1/2?
Oh, did you guys get negative 1/2? Sorry. Okay, thanks. Negative 9 minus 9 plus 7. Yeah, negative 2. Okay, let me change that. Okay, double check my 10. Is that what you guys got? 3 halves, 7 halves, negative 1/2, negative 3 halves. Okay. All right, 11. Okay. Any questions with number 11? Okay, number 12 says find the value for the missing element that would allow for matrix F to be singular. So singular matrix just means that your inverse does not exist. So for your inverse to not exist, that means your determinant must be equal to what? 0. So we're going to basically create a situation that will allow for the determinant to be 0. So all we're going to do here, we're just going to set AD minus BC equal to 0, and then that will allow us to solve for X. We can figure out the X that will allow the determinant to be 0. So I'm going to set up my determinant, AD minus BC equal to 0, and then I can look at that equation and figure out what X must be. Negative 16 plus X equals 0. Solve for X. X must be 16. So if 16 was in place of X, and if I went back and I tried to find the determinant, I would get 0. And if I get a 0 for the determinant, I know that my inverse does not exist. Guys, I just want to check this worksheet. I'm not going to check the rest of your packet till tomorrow, but let me just check your worksheet. Tomorrow, I'll check your second worksheet and your packet, okay? Just everything that we've done last week.
Sorry.
Rachel.